Developers. I'm joking. My name is Eric Allen. I can be found on Twitter at _EJAllDay_. Give me a follow, and I'm going to be posting my slides as soon as the talk is over. The title of my talk is The New HotNess, Hard Lessons Migrating from REST APIs to GraphQL. And today we are going to talk about mistakes and frustration, and how we as developers sometimes make decisions that have far greater consequences than we initially calculate. We're going to dive into some code, and I'm going to demonstrate how to eliminate N+1 queries in GraphQL. And if you're not familiar with what an N+1 query is, that's okay. N+1 queries present themselves when we query our databases for a collection of records and want to get back associated objects. In this case, if we wanted to select 10 countries, 10 being the letter N, in all their cities, it would take us N+1 or 11 queries to fetch the same data that we could easily fetch in one query. We're also going to talk about how to think differently about making mistakes and how we can make better decisions as engineers. Back in January, when I wrote the abstract for this talk, I was pretty stressed out. Our team worked really hard in 2018. We had just completed a front-end rewrite, migrating from a 6-year-old backbone implementation to React. And at the same time, we migrated from a REST API to GraphQL. On Monday, January 7th of this year, when we all showed up to work, I think we were all sort of looking for a bit of a fresh start. And instead, we realized that we had some pretty serious problems. That morning, I logged into our New Relic instance, and our AppTex score was at 0.82, which was the lowest I'd seen it since I started at the company. Throughput was spiking to about 2,500 requests per minute, and response times were anywhere from 2 to 10 seconds. Now, this isn't catastrophic by any means, but we were receiving feedback from our customers that our application was unusually slow. And for a team that takes as much pride in our work as we do, this just felt flat out unacceptable to us. And so when we started to peel back the layers of the issues that we were having, we discovered 3 key issues. The first of which was a memory leak in React. The leak is associated with password input fields, and when they get rendered into the DOM, there's an event listener that gets added, and that event listener prevents every node and every child node from being garbage collected properly. If you're so inclined, find this tweet on Twitter. We have a sample application up on GitHub that demonstrates the issue, and feel free to give a thumbs up to the issue. Because even though we were able to sort of isolate it in our application, the issue is still outstanding today. The second thing we discovered is that some of our architecture decisions that we made on our new React implementation was severely increasing throughput. We were making a lot more small requests that ordinarily would take 60 milliseconds or so, but the accumulation of so many requests was maxing out our database connection pool. And so we had requests bottlenecking at the database layer. They were waiting in middleware. And so a request that would ordinarily take 60 milliseconds was taking, like I said, anywhere from 2 to 10 seconds. And all of these problems were exacerbated by the fact that GraphQL had introduced N+1 queries everywhere in our app. So how did we get here? How did that happen? Before we move forward, I just want to pause for a brief moment and acknowledge that simply giving this talk sort of puts me and my team in a bit of a vulnerable position. I didn't ask for their permission before I wrote the abstract, primarily because I never thought it would get accepted. And in the process of writing the talk, it's really forced me to sort of confront a lot of my own fears and feelings of imposter syndrome throughout my career, because I didn't come from a traditional software background. I've been writing software for about 7 years now, but I come from a finance background, and I've worked in sales and marketing, and so having to stand up here and basically talk about mistakes was a little bit difficult for me. But luckily for me, the team that I work for is incredibly supportive, and we value learning over everything else. So to the people who have been supportive of me at both CirrusMD and throughout my career, I just want to take a second to say thank you, because it means a lot to me. So like I said, everywhere I've worked, I started out my career at Thoughtbot, moved on to LO, went on to Pivotal Labs, and now I work at SiriusMD. It's been a huge privilege to work around insanely talented engineers. But when you're surrounded by engineers that are this talented, the bar is set extremely high. And so in the back of my mind, I'd always sworn that I would never, submit an abstract or give a talk unless somehow I'd convinced myself that the subject matter was technically valuable enough, whatever that means. And like I said, here I am giving a talk about mistakes. So when the talk was accepted, I had kind of an epic panic moment, and I did what most people, I think, would do. And so I just Googled how to give a technical talk. And after a bunch of research and looking at blog posts and seeing other people's talks, ultimately, most people just say, you have to figure out, why are you here? And why am I about to take up 40 minutes of your time? And for me, there's a few reasons. First and foremost, I'm really passionate about the work that I do, specifically performance and API design. I also really like decisions that are good for business. I think a huge part of our jobs as engineers is to make really quality, well-thought-out decisions that never put our customers or our own businesses at risk. And I think at times our judgment can be really clouded because we want to learn new things and work with new tools. And perhaps in those moments, we fail to consider the full cost of our decisions to the business. I think that we as a community can do a better job acknowledging and talking more openly about the fact that we're often forced to make really big decisions with limited amounts of information. We make these huge bets on technologies when it's impossible to calculate the short-term or the long-term cost of those decisions. And lastly, I wanted to give this talk because I care a lot about this community. And I've really enjoyed working with GraphQL, and I'm hoping that by sharing some of the struggles that we had, it might make someone else's transition a little bit smoother. So before we jump into the code, I just want to paint a small picture for you of what our app does. I've done my best to strip away as much of the domain knowledge and context as I can so that the code will just speak for itself. But I do think that having a basic understanding of what we do will help the code to come alive and make it a little bit easier to understand. So I work for SiriusMD, where we have created a HIPAA-compliant medical chat platform that is focused on providing patients with barrier-free access to an unparalleled virtual care experience. So what does that mean exactly? It basically means that anyone with access to our platform can log in and within a matter of seconds be chatting with a doctor, a pharmacist, a financial counselor, whatever your medical need dictates. And this is a screenshot from a chat. I'm glad that they decided that grinding was a really good thing to do right now in the middle of my talk. Anyway, this is a screenshot from a chat that I recently had about my son Arthur when he wasn't feeling well. On login, a patient sees a stream. And a patient can have many streams. Like I said, a stream is tied to what type of care you're getting. So maybe it's a pharmacist or a doctor or a financial counselor. And so when you log in, the plan is notated at the top. So you can see this is the SiriusMD employee plan. And each stream has many messages, and that message has an author, and that author can either be a patient or a provider. And when the chat is completed, we sort of wrap up all of those things into what we call our encounter. And the encounter gives the chat sort of like a level of finality. It lets us know that it's finished. And on the surface, this probably looks like a lot of other chat applications that you have worked with. But in our space, the object relationships can be subtly complicated. So like I said, we have many streams. And a stream belongs to a plan, and a plan has the name with some operating hours. We also have our encounter object, like I said, that wraps all those messages up. And then we have our authors. We have patients and we have providers. And then over here to your far right, we have our credential object, which is the object that we use for authentication. That's where emails and passwords are stored. So when a user logs in, naturally, they might hit their streams endpoint to go and fetch their collection of respective streams that belong to their experience, right? But what happens when you're logging in and you're not on the web application? What if you're using our iOS client or your Android client, right? Those platforms are going to have different data needs. And their connections are probably going to be less performant than our web app, right? Simply based on their connection. And so if you've ever had to maintain a REST API, you probably understand the struggle of trying to write one API that serves all the respective needs of each client. Or you know the pain of trying to maintain multiple APIs specific to each client type. These problems are really, really costly for businesses. You have to write and maintain the documentation. You have to worry about backwards compatibility. Your path to delivery can be a lot slower because your API team has to be in constant communication with each of the teams that maintain the clients and make sure that they're getting back the data that they need in the shape that they need it. And that's exactly why we wanted to move to GraphQL. For those of you who may not be familiar with GraphQL, GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of that data in your API and gives clients the power to ask for exactly what they need and nothing more. It makes it easier to evolve APIs over time and enables powerful developer tools. So GraphQL APIs are organized in terms of types and fields, not endpoints. With GraphQL, you define a type system with queries and mutations, effectively setting up some guardrails around your data, and then each consumer has complete flexibility within those guardrails to query the data however they want. The result of this is an introspectable API that self-documents, shows us how to query it, and our perception at SiriusMD was that the flexibility would allow for greater autonomy between our clients, we'd have faster cycle times, there'd be less coupling between our API and our clients, and then not maintaining the documentation was probably going to be my favorite part. So on the surface, a GraphQL API doesn't actually look all that different from a REST API. You know, in REST, we have many controllers and actions. We have index actions and show actions for reading our data, and we have update and delete actions for modifying it. So in this example, we have our streams index, which is obviously going to return a collection of our streams. And in GraphQL, we have many queries to read our data, and we have mutations for modifying data. In this particular case, we have our streams resolver. That streams resolver maps to our streams query, and this resolver will essentially return the same data that our streams index action would return. So in REST, we have serializers. In GraphQL, we have types. In both cases, we're using these objects to determine the structure of the data that we're going to return from our API. In our serializers, we define attributes and relationships. In our GraphQL type objects, we define fields for both our attributes and relationships. In our serializers, those relationships rely on other serializers. In our GraphQL type objects, those field relationships rely on other type objects. So why, with all of these similarities, when we're requesting essentially the same data, does GraphQL produce N+1 queries, whereas REST does not? Well, this sort of brings us to our first lesson and the first mistake that we made, and that's eager loading. The first mistake we made when implementing our resolvers in GraphQL was assuming that eager loading would be respected the same way that it would in a RESTful controller action. But if you take a step back and you think about the greatest fundamental difference between GraphQL and a REST API, it's that in REST, we sort of know exactly what the client will ask for because it's predetermined ahead of time. You know, we have our routes file, and that routes file tells us all the different options that we have. It's like a menu of endpoints, right? And every time we hit one of those endpoints, we're always going to return the exact same data. So it's really easy when you have that data to write really efficient queries and load all that data in the most efficient manner possible. But in GraphQL, we never know what the client might ask for. So if you think about it, eager loading in GraphQL is sort of an anti-pattern because you're probably going to be, because even if it did work, you'd probably end up loading a lot more data than you necessarily need for each request. So as an example, this is a streams query. And in this example, you can see that we're requesting an active encounter, which is an encounter object, and then the provider that's tied to that, and a patient and a plan. And this might be a typical request in GraphQL. But what happens if, for whatever reason, one of our clients only really needs a collection of our stream IDs? Well, they can use the exact same query string and just pare it down to only request the ID. So again, if we have no idea what the client's going to ask for, how can we make sure that we're efficiently loading those objects? Well, first things first, we're going to remove all eager loading from our resolvers. So now, when we load a collection of streams, each one of those stream objects that we get back from this collection is going to be handed into our stream type object. As it stands right now, with no eager loading or anything, when each stream gets handed into this type object, we're going to be triggering an additional query for the active encounter, the patient, and the plan. So if we were to fetch 10 streams, we'd be adding 3 additional queries per stream right now. Not to mention any additional queries that would be triggered by the underlying objects or relationships in those types. This is very inefficient. And as you can imagine, we were not the first engineers to come across this problem. Lucky for us, the wonderful people at Shopify have created GraphQL Batch. GraphQL Batch provides an executor for the GraphQL gem, which allows queries to be batched together. To leverage batching, we install the gem. There's a couple lines of setup code, and then we need to define some custom loader objects. So we have a record loader, and we have association loaders. This I literally pulled directly from their documentation, just as an example. You can also modify these objects if you see fit, if that makes sense for your application. So in order to eliminate those extra queries, we go back to our type. We define methods for each of those object references, so the active encounter, the patient, and the plan. Within these methods, we leverage our newly defined loader objects. And then what we need to do is we need to do the same thing for every other one of our type objects. So any object relationships in any of our GraphQL type objects need to have their relationships defined this way with the loader objects. Once we're done doing that, we go back, we run our streams query, we look at our logs, and it looks like we've eliminated some of our N+1 queries, but not all of them. Which brings us to our second lesson, delegation. Here, we see our stream type, and we have a patient relationship with that stream. When that patient object is handed into the patient type, we use our record loader to ensure that we're batching all of those patient queries together. And everything seems good, right? Everything looks cool. So let's go take a look at the patient type object. Well, on first look, when I look at this object, my instinct is to think that there's no additional work to do here because I don't see any object relationships. I don't see any other types being leveraged. So I'm scratching my head and I'm thinking, where is this extra query coming from? Well, if we dig a little bit deeper and we look at our patient class, we realize that one of the biggest benefits in Rails is how easy it is to interact with complex object models and create a language around your domain that actually makes sense and is easy to read. So easy to read, in fact, that sometimes you forget where the data is actually coming from in the first place. So you guys remember that patient credential object that I mentioned earlier, the object that we use to store emails and passwords? Well, both patients and providers have a credential relationship. But that credential object is not really meant to be interacted with directly from our API. And so we delegate to it. So when we call patient.email, we're actually calling patient.credential.email. And this subtle line of code, one that we use frequently in Rails, is a hidden N+1 query waiting to happen in GraphQL. So how do we solve this one? Well, we go back to our patient type, and we define a method for the email, just like we did for any other relationship. And notice the .then syntax. Our record loader object is actually returning a promise. And by calling then on the returned promise from our record loader, we gain access to the credential and are able to grab the email property from it while avoiding extra queries because we've now batched all those credential queries together. We go back, we run our query, we check our logs again, and you can see that we've batched together our credential queries, but we still have other N+1 queries elsewhere, which leads us to our third mistake, which was how we leverage our service objects and decorators. So we use service objects and decorators when we need to present data in a specific way based on one or more factors. For our application, each plan has a predetermined set of business hours. If a patient tries to log in outside of those business hours, we need an intelligent way to inform the patient that a provider will get back to them as soon as we're open for business. So when we fetch a stream, we hand this message back with the active encounter. The active encounter object then gets handed to the encounter type, and inside the encounter type, we have a field defined for the patient queue status and a method that calls out to our patient queue status object. And as you can see, we've defined this with a method signature where we hand in our encounter object. So let's go take a look at this object. In real life, this object is a lot more complicated. However, we can see that in this contrived example, that even though I'm handing in the encounter, we also need the plan and we need the stream. Now, in a REST API where eager loading is being respected, this might not be a big deal. But in GraphQL, this is just one more N+1 query waiting to happen. So how do we fix this problem? Well, in order to hand back the queue status message without introducing that N+1 query, we need to load all of the objects that the patient queue status relies on ahead of time. We also need to update the method signature to allow us to hand in all those objects together. So to do this, we again leverage our record loader objects, and we define a method for our stream object and our plan object. But in this case, because our queue status object needs the encounter, plan, and stream objects all to be present before it can be called, and we don't really know when those promises will resolve, we use the promise.all syntax to ensure that all of those objects are present prior to calling our patient queue status object. So with that last update, we check our server logs, and voila, all of our N+1 queries for our stream resolver are gone. So let's do a quick recap of what we've learned. Eager loading will not be respected with deeply nested objects in GraphQL, so we need to use loaders to query our objects efficiently. Method delegation to associated objects will introduce N+1 queries where you least expect them. And decorators and service objects that are called from your types need to explicitly preload all the data they rely on, or they will also introduce N+1 queries. So today, on that same instance, our AppDex score is 1.0. The average response times are about 60 milliseconds. And as you can see, we average around 550 requests per minute. So let's do a quick retro on our decision to go with GraphQL. What do we gain? Well, I think the first thing, and probably the most important thing, is just an enormous amount of flexibility with how we interact with our API. I've noticed over time that we are making far fewer changes to our API as we've introduced new features on the front end. I can't speak to our Android and iOS clients because we've just started the undertaking of migrating those clients over to GraphQL, but we are extremely excited about it, and we think that it's going to be equally as flexible there. We also got free documentation, which is my favorite part. Anyone who's had to maintain an API knows that maintaining documentation is extremely laborious, so that's been awesome. I also think we have to acknowledge, though, that we took on some new dependencies. And what that means is that from this point forward in our application, we now have to maintain those dependencies. And we have to rely on the goodness of the open source community to make sure that we are up to date and that it's secure, especially in our space. Let's talk about some things that we gave up. Well, we gave up some confidence, to be honest, initially, both internally on our team and externally with our clients, albeit for a short period of time. We also gave up HTTP response codes. One thing I wasn't aware of when we first started in with GraphQL is that GraphQL always returns a 200, no matter what, unless you somehow spoof that. So even if you get an error, GraphQL responds with a 200, and then it has an error key inside of the response. And so I could give an entirely different talk on how to handle error messaging in GraphQL and how that's different from like a normal REST API. It seems like a subtle thing, but when you're not getting a 401 or a 404 and error handling is completely different, you have to think about it in a whole new way. We also lost some granularity in our performance monitoring. I think what happens sometimes is that our application is 7 years old now, and over time you just sort of get used to the tools that you're using, and you sort of take them for granted. We had already been using the bullet gem to identify N+1 queries in our REST API, and I think we just sort of assumed at some layer that a lot of these same tools would just work well with GraphQL, and unfortunately they're not built for that. Same thing is true for New Relic. In our domain space, because we have to be HIPAA compliant and HITRUST certified, 80% of the New Relic API is basically eliminated for us because we have to enable high security mode. And so when you only have one endpoint that your entire app uses in GraphQL versus a whole category of endpoints, it makes it much more difficult without adding a whole bunch of extra code to see what the problem is inside of a transaction trace. I think we also have to acknowledge that whenever you migrate from one technology to another, there's an opportunity cost to that. We could have spent a lot of the time that we were doing on this migration from REST to GraphQL on other features. And I know that hindsight's always 20/20, but I do think we have to consider this when we're making our decisions. So how can we approach making these types of decisions differently? At the beginning of this talk, I started out by saying that I believe there's a huge part of our job as engineers is to make quality, well-thought-out decisions that never put our own businesses or our customers' businesses at risk. And I also said that I think we can do a better job as a community to acknowledge and talk more openly about the fact that we're often forced to make really big decisions with limited amounts of information. I've always sort of felt this way. And because of my non-traditional software background, I've always sort of struggled to articulate myself with engineers who come from CS backgrounds who are really, really bullish on working with new technologies and learning new things and machine learning or AI or whatever it happens to be at that time. And they don't necessarily, at least in my experience, they don't always want to talk about how the decisions we're going to make is going to affect the business. And that was until recently when our CTO shared a podcast that featured Annie Duke, who's a former professional poker player. And she was talking about her book that just came out called Thinking in Bets. I was absolutely blown away by this podcast, because even though it has nothing to do with software, it has everything to do with making quality decisions. So let's talk about some of the ideas that I learned from this for making better decisions. How many people in this room have ever been in a meeting where somebody presented an opinion or an idea as a fact? Right? Pretty much everybody. We have to remove opinions that are presented as facts. Presenting opinions or ideas as a fact is a toxic behavior. And what it does is it creates an environment that's uncomfortable, and it discourages other people from giving input. Because when an idea or an opinion is presented as a fact, or with 100% certainty, it immediately shuts other ideas down, because in order for someone else to contribute another viewpoint, they essentially have to imply that the idea that was just presented as a fact might actually be wrong. It forces us into conversations about right versus wrong instead of discussing the costs and benefits of a particular decision or idea. I also think we need to get a little bit more comfortable with saying, I don't know, or I'm not sure. And I feel like sometimes we're discouraged from saying, I don't know, because it's perceived as being like evasive or vague. But getting comfortable with saying I don't know or I'm not sure is a vital step in becoming a better decision maker. By getting comfortable with saying I'm not sure, we're essentially embracing uncertainty. And by embracing uncertainty, we're bettering our decision-making process, because good decision-making processes include accurately representing the level of uncertainty about a given decision or option. So instead of saying GraphQL is the right decision, what if instead we said, I'm about 75% sure that GraphQL is the right decision. Simply by saying we're 75% and acknowledging that uncertainty exists opens the door for other people and makes it much easier for them to tell us what they know about this problem and contribute to the discussion. Once a decision has been made, we need to acknowledge that what makes a decision great is not necessarily that it has a great outcome. Sometimes we make really great decisions and things just don't work out for any number of reasons, and that doesn't necessarily make the decision a bad one. A great decision is the result of a good process. Accurately evaluating unknowns and making the best decision with the information we have is a good process. Drawing an overly tight relationship between a decision and its outcome is what Annie refers to as resulting. Working backward from results to figure out why those things happened leads to cognitive traps, like assuming causation when there's only correlation, and it doesn't really leave room for that uncertainty that is always going to exist. And these traps lead to terrible decisions in the future. Speaking of terrible decisions, how about we remove any bias from choosing a technology simply because we want to learn something new? How about we just call it out and be transparent about our own wants and needs so that those wants and needs don't necessarily overshadow a decision and lead us to making a decision that won't necessarily be good for our business. Lastly, I think we should embrace mistakes. It doesn't ever feel good to have to admit when we make a mistake. Society teaches us that mistakes are shameful. But what if instead of feeling bad when we have to admit that we made a mistake, what if the bad feeling actually came from the thought that we might be missing out on an opportunity to learn something, just to avoid the shame or the blame of having to say, hey, I messed up? The shame or blame that, in my opinion, shouldn't exist in the first place. So I propose that instead we hold each other accountable for this, and we embrace people who admit making mistakes so that we might learn something new. Let's rewire our brains to bring less certainty and more empathy to our conversations, and let's get excited when a teammate walks up and says, hey, I think we made a mistake. Thanks. I did leave some time at the end for questions. I'll do my best to repeat them and remember to do that. So, So what I mean by free documentation is that there is a tool with GraphQL called Graphical. And inside of your Chrome developer tools, you can go in there and you can use Graphical. And what Graphical does is, I can actually, I'll go back to that slide. Hang on just a second. So Here you go. So you can see here that like at the top we have our patient profile query and we have WebSocket stuff and current dependents and patient profiles and stream data and whatever, right? So basically what you see here is you see a menu of all the different query strings that we accept in our API. And then what you can do is you can use this tool to build out exactly the query that you want. So in this particular case, you can see here we have our stream, and that stream has all these different fields that you can query for. So maybe you need allergies or their date of birth or history or whatever. And so what you can do is if you don't actually need that data for any particular request, you can just remove it. Like you don't have to ask for the patient. And so essentially what this is like all of the API documentation you could ever need because it's interactive. And anybody who's going to be consuming this, all they have to do is go here, look at the different queries that are available, and there you go. I mean, it's actually quite awesome. It's fun to play with too. That's what's one of the awesome things. So the question was, there's a lot of other gyms that are built on top of GraphQL Batch, and whether or not we've experimented with any of those at this point. And the answer is no, we haven't yet. What I was about to say, one of the best things about this community is like how quickly things move and how many new gyms and stuff getting introduced. And even since I started writing this talk, I have discovered like 2 other tools. But unfortunately, obviously what we have to do over time is we have to like make the best decision that we can with the information at the time and move forward with that one. And I think that as we start to discover those tools and they become more and more mature, we'll probably experiment with some of those things. I'm pretty conservative when it comes to choosing tools. That's one of the reasons I love working in Rails so much. I like things that make sense and that work and that are well maintained and well supported, and especially in our space where we're dealing with healthcare, and so we have to be very, very judicious about choosing which tools to use because we have to make sure that our application is compliant.
I ask because we got burned by one of those gyms.
Yeah, I mean, to take it back to what DHH said in his talk, anytime we choose a tool or whatever, it's like we're relying on the goodness of the open source community, and I think, my hope is that, as part of this process of using GraphQL, we'll be able to, discover some things and actually contribute back to that, because so far we've just been consumers. Oh, I knew this was coming. Okay, the question was, I told you at the beginning, or at least in my abstract, that I would tell you whether or not I would do this all over again. The reason I didn't specifically address that in my talk is because I'm very hesitant to make any blanket statements or assertions or present an idea as a fact about whether or not GraphQL might be right. Because I don't want to encourage or discourage anyone who's thinking about using GraphQL from doing so. I will say this, based on my personal experience and based in our domain space where we have APIs that are consumed by multiple clients, the answer is yes. I would definitely do this again. If I was working on an application where I'm only dealing with one client and it's pretty, I wouldn't do this because the flexibility is really where the power comes in, specifically for all your different clients. That's my opinion. And I think also, if I was like, Rails newing tomorrow, I would probably use GraphQL again, just because I've really enjoyed the experience, and I like I said, I've enjoyed the developer tools. So I won't say whether you should or you shouldn't, and if anybody has questions about or about whether you should or shouldn't, I'm more than happy to have that conversation afterward. So the question was, how do we monitor or how do we implement like more fine-grained access depending on like attributes that like maybe one user has access to and one user doesn't have access to. GraphQL has support in their gem for pundit, and if you check out the GraphQL Ruby documentation, there is a lot of support in there for doing that type of thing. Within our domain space, we don't. We kind of control all the consumers of our API, so this is not a public-facing API, except for like we have other SSO integrations and stuff with some of our customers, but we control that stuff now, so it's less of a concern for us. So I'm not as familiar with those tools, but for public-facing APIs, I know that there is support for that. So the question is, because GraphQL always returns a 200, how do we handle our error responses? Well, that's a really good question. Basically, we do a lot of graceful failover, a ton. We use an interactor pattern in our application, and we've essentially engineered it so that, we hope that we actually never get an error message, and we get very few of them at this point. But whenever we do, we have handling on the front end that understands that if that key happens to exist, what to do with it. And so I think that there's probably some room for improvement in how we handle those things. But I have been focusing the vast majority of my time on the back end of this stuff and less of our time in the React stuff. My experience with mutational queries is honestly, the question was, sorry, what is my experience with mutational queries, not just queries that are reading data but writing data? And honestly, it feels, to me, it's like pretty much tomato, tomato. It's pretty much the same thing. We use, like I said, we use an interactive pattern where we have objects that are specifically responsible for creating data or whatever. And actually, I'm glad you asked that question because one of the things that I learned about our application when we made this migration was how well we had architected it and how the people who came way before me architected it. Because when we switched over from REST to GraphQL, there was very little that we needed to do in terms of interacting with the objects that were responsible for doing a thing, right? So like when we create a message, that has to do a bunch of additional stuff, right? We have push notifications that go out and all kinds of other things, right? But all of that object was abstracted to the, all those responsibilities were abstracted to the correct layer. And so when we moved over to GraphQL, all we had to do is instead of calling that object from our REST controller, we just called that same action from our GraphQL. And so it made the transition really smooth. The question is, do I personally use GraphQL Pro? And if so, which features do I use? We do not currently subscribe to GraphQL Pro. We have considered it. One of the other things that I don't talk about in my talk is that during the time of our migration from REST to GraphQL, the GraphQL Ruby gem underwent like a massive overhaul, right? They used to have a function-based syntax, they moved to a class-based syntax, and so as part of that process, we were a little bit hesitant to go further with it until it was more fully baked and solid. And so I know that it's very stable today, and it's been worked out great for us. But we haven't gone to that next step yet. It doesn't mean that we won't. We've definitely considered it, but not yet. I'm actually out of time. So if anybody else has questions, please come see me. We have some T-shirts and stickers and stuff for y'all. So thank you so much for your time. I really appreciate it. And if you have feedback,